Lesson 35 is all about locating and using intercepts. In each of the example problems, we're going to learn how to do a new skill when it comes to dealing with the solution to a set of linear equations. In the very portion that you're going to read through in the new concepts, it says that a solution to a set of linear equations is two variables, an x and y in ordered pair. One of those special solutions happens to be the x-intercept and the y-intercept, where on a graph, any line crosses and hits both of those points. Now those are often represented by an ordered pair, an x and a y. Those x-intercepts always show up in this form where x is the variable, the number on this horizontal axis, either negative this way or positive this way, and then y equals 0. Your x-intercept always will be in this ordered pair form. Your y-intercept will be the opposite. X is going to equal 0 and y is going to be your value, either positive if it's in this upward portion or negative if it's in this downward portion. Now, when you're finding those x and y intercepts, there's a couple strategies that we're going to look at in our practice problem. But before that, one of the other new things that they're teaching you is this idea of standard form. Most of the time, you've seen equations written in y equals mx plus b, which is slope-intercept form, where m equals the slope and b is the y-intercept. Well, you can change and rearrange this equation so that you have both of the variables x and y on the same side by doing opposite operations. If you need to add or subtract to move something to one side, you do it to the other side, which puts the x and the y on the same side. Again, I'll show you that in our practice problems. But here's standard form, which is ax plus by equals c, where a, b, and c are going to be variables that go along with the important portions, the x and y, the ordered pairs that make up the different points of a line that is graphed. If you're using a graph to find x and y intercepts, anywhere that this graph intercepts, you're going to try and find the y-axis and the x-axis. You can do that by simply looking at the graph. If you have Desmos.com open on your computer, you can type in the equation and then click on those specific points to find where those x and y intercepts are. Otherwise, you're simply counting up or down on your y-axis, left or right on your x-axis to find where those ordered pairs are, and they should show up in this form. Now let's take a look at a couple of the example problems from the lesson practice today. That way we can practice what it teaches us and will be applied in our homework. In example 1, it asks us to find the x and y intercepts given an equation that looks like this. You've got negative 6x plus 9y equals 36. How do I find the x-intercept and the y-intercept? Well, I just learned that the form for those are going to be written with the opposite value being a 0. So if I need to find the x-intercept, I turn y into a 0. Let's try that. Negative 6x plus 9 times 0 equals 36. What's that going to get for me? Let's solve it. 9 times 0 is 0, so that's going to disappear. So I get negative 6x equals 36. To solve that, I would do the opposite operation. Divide by 6, divide by 6. I know that 36 divided by negative 6 is going to give me x equals negative 6. Now I got to do that all over again because my x-intercept is negative 6. Written out as an ordered pair is negative 6, 0. My y-intercept is going to look like this. Because I know whenever I'm looking for a y-intercept, the x equals 0, I rewrite the equation and I plug in a 0 for x. Plus 9y equals 36. This will be canceled out because anything times 0 is 0. So I get 9y equals 36. Divide by 9. Divide by 9. 36 divided by 9 is 4. Y equals 4. If it's written in an ordered pair form, the x is written as a 0 and the y is written as the value that we solved for. Okay? To find an x or y intercept from an equation, you plug in a 0 for the opposite value that you're trying to solve for. In letter B, it says graph 4x plus 7y using the x and y intercepts. Okay, to do that, I'm going to use the same type of situation here, where I plug in a 0 for the x or the y, solve for the opposite value. So plug in 0 for x to find my y-intercept, 7y equals 28, divide by 7, y equals 4. If I'm going to graph that, I know that the y value of 4 is actually represented in an ordered pair of x equaling 0 and y equaling 4. Now I can graph that point. If x equals 0, I stay right here and I go up 1, 2, 3, 4. There's my y-intercept. Now I should use that same strategy again to find my x-intercept. To find the x-intercept, I plug in a 0 for y. So I would have 4x plus 7 times 0 equals 28. In this case, 7 times 0 is going to be 0. That'll cancel out. I've got 4x equals 28 Rewrite that, and then solve for x. To get x by itself, we do the opposite operation. Divide by 4, divide by 4, 28 divided by 4, x equals 7. Now to write that as an ordered pair, I remember that the value goes into the x location, and the y variable is going to be a 0 in this case. So x equals 7 graphed like this. 1, 2, 3, 4, 5, 6, 7. There's my point. If I've got 2 points, I'm going to try and draw the straightest line I can. Attach arrows to the sides, show that that's continuing that way, and now I have my graph completed based on that. You could also type that into decimals just to see if that is correct, to check your work when you're graphing manually with that graphing calculator resource. In letter C, it asks us to find the x and y intercept on the graph that's already created for us. Here you're simply using your skills and knowledge of ordered pairs to find where those variables are. You know that this is the y-axis, so this is going to give you your y-intercept here at this point, and this is the x-axis, so it's going to give you your x-intercept here at this point. To find the x-intercept, I know that my y is 0, and to find the y-intercept, I know that my x is 0. So let's just write that out. This is going to equal the x-intercept, this is going to give me my y-intercept. Let's find those. The x-intercept is where I'm on the x-axis, and it looks like I'm at -2, -4, -6, -8, 0. The y-intercept looks like I'm at -2, -4, -6, 7, 8, 9, -9. I'm simply finding that point by my knowledge of how ordered pairs work and writing those out. You could also write that as the x-intercept equals -8 and the y-intercept equals -9. In ordered pair form or written out as it equals to, I'd be happy to accept either one of those answers. You're showing me that you know how to find that x and y intercept. In letter D, it says write 4y equals 12x minus 12 in standard form, then graph the equation using your x and y intercepts. To write this in standard form means we need to put the x and y on the same side. Remember, standard form looks like this. Ax plus by equals c. That means I need to get this x to this side. Here I'm going to subtract 12x. If I do something to one side, I do it to the other side. Subtract 12x from this side. Because these are not like terms, they're going to both stay separate on this side, and I can just rewrite my equation. -12x is a positive 4y equals -12. These two would cancel, and I now have my new equation. I'm not going to do it because I've just done it 2 different times. How to go back and find your x and y intercepts. You plug in a 0 for your x to find your y intercept. Plug in a 0 for y to find your x-intercept, and then solve using the method that we just practiced. And from that, you could go ahead and graph. You could also plug this into your decimals calculator and find those x and y intercepts by clicking on the points where they cross the x and y axis lines. Lastly, in letter E, it's got another application that is similar to the one in example 5. Letter E says, Herva jogs 6 miles per hour and bikes 12 miles per hour. The equation 6x plus 12y equals 24 shows that she has gone a total of 24 miles. Find the x-intercept and explain what each means. So she jogs 6 miles per hour, she rides a bike 12 miles per hour to a total of 24. What this means is what we're looking for is that she's trying to go this many hours a day in order to get this many miles accomplished. Her goal is to get 24 miles accomplished. How many hours does she need to run or ride her bike in order to get that many miles accomplished? If she rides 6 miles per hour and 12 miles per hour, how many hours does she need to run and bike in order to get her 24 miles accomplished? Well, to find this, let's find the extremes of this. If I was just going to run to try and get my 24 miles, how many hours would I need to run? If I was just going to bike, how many hours would I need to bike to get 24 miles accomplished? Again, here's my strategy. To find the x-intercept, I plug in a 0 for y. Plug in 0, that's going to cancel. My new equation looks like this. 6 equals 24. Divide by 6, divide by 6. 6 is canceled. 24 divided by 6. X equals 4. That means if Herva's going to make it 24 miles just by running, she's got to run 6 miles per hour. She's got to run 4 hours in order to get those 24 miles completed. If she's going to bike, she's got to do the opposite. Plug in a 0 for x. That's going to turn into 6 times 0 is 0, so I got 12y equals 4. Divide by 12, divide by 12. 24 divided by 12, y equals 2. If I'm going to make it 24 miles biking, I need to bike for 2 full hours because I go 12 miles per hour on her bike. That's what both of those extremes mean. Now, if we're trying to calculate this with other variables besides the intercepts, you're probably going to get some combination. Maybe she runs for an hour and gets 6 miles done, and then bikes for the rest to get the 24 miles based on those speeds that she's traveling. You can see this can be used in a real-world example. What you need to remember today is how to get something into standard form, how to find those intercepts by using our plug-in zero method to isolate those items, and then how to obviously graph those points and graph those equations based on where those x-intercepts are. If I've got 2 points, I can graph any type of equation. Your homework for today is your practice problems. They should be circled on your homework sheet. God's blessings.